everyone. I think some of us, we've actually been in touch, and we are trying to get regular with the Zingg events. So really thrilled that you people have, joined in today. Would love to get some bit of an introduction, and then I'll, just pass over to Sam, who would be conducting the session today. So, Amne, would you like to go first? Oops. Hello, Amne. Okay. Jason, would you like to introduce yourself? I'm sorry, my power went off, so I'm not visible right now.
Oh yeah, sure. Sorry. My name is Jason. I'm a software engineer at the ACLU, and yeah, we looked into Zingg for entity resolution last year, and I've been looking into Spark Connect, so I've been interested in that. So I wanted to get some more info on that. Yeah.
So welcome, Jason and Anme. It's Amne, right? Pavli, how about you? Did I get your name correct?
Yeah, it's correct. So yeah, I work. I'm from Belgrade. I work as MLOps on Databricks, so mostly about like DevOps part. So I'm interested in Spark Connect.
Okay, welcome. I
Thank
hope
you.
this is useful to you. How about you,
Thank you.
Tejas? Tejas, can you hear us?
Yeah, can you hear me?
Yes.
Yeah, so I basically work in TransUnion, the same domain as entity resolution.
Oh, wow. Okay.
So
So
I'm
are
a
you
little curious to know like how this field works. That's why I joined.
Okay. So today's session, just for the record, is not that much about Zing, but it's more about Spark Connect and what we are doing with, and we'll cover later the next session, what we plan to do with Spark Connect and Zing. But I hope you'll still find this useful. And anytime you want to talk entity resolution, just let us know. We have a Slack full of people, 650 plus. So do join in our community if you're interested.
Yeah.
How about you, Jeevaj?
Yeah, hi. I'm a full stack developer. Yeah, we are basically JavaScript. I write code in JavaScript, and uh, I came across entity resolution when I came across the term called as fuzzy search when I was in my last company, where we faced few problems with respect to duplications of the records, basically, which we were not able to filter out. So let's see. I'm more interested in learning more about it. I'm not yet tried completely. I want to learn more about how I would have made API and integrate like automating things. I have seen the documentation I need to run Docker and all, but I was not that comfortable because as a developer, like full stack developer, I'm more comfortable in endpoints, like what payload I should give. Like I have that thinking, or I have that mindset. So I was thinking if I can make something like that of kind, like sending some payload and getting some response, like that thing. So that was my interest, basically. Yeah.
And how about you, Abhishek? Hello, Abhishek.
Hello. Are you able to hear me out?
Yes, we can hear you.
Hey, hi, Sonal. How are you?
Yeah, good. Nice to meet you.
Yeah, nice to meet you too. Yeah, so I just joined in a little bit late. I just got 10 minutes late rushing to the office. So, so yeah, even I have tried the Jing version actually. Like I just followed the documentation. I'm able to run it, but I follow like I ran into some of the issues. I think the documentation on the website is with the 0.3 version, and like I think the recent Zingg jar which I downloaded is for 0.4, right? And also, like, I want to know, like, there are certain, like we are just in the evaluation phase right now, and we are just evaluating different things which we can use it for the better entity resolution for different entities. So, so the one thing which we want to know is like, do we have, like, suppose we just want to identify the like I think we get the unique cluster ID for all the duplicate records in the data set, right? So my thing is like, is there a way, like, how can we confirm that there is no data going outside from us? Like what are the different things which are getting tracked? So those are the things I'm interested in right now.
Sure. So I think I'll defer the Zing discussion to post the session. I can stay behind and answer some of the questions for the audience, which are Zing specific. Today specifically, at least for this current session, we have a guest with us who's Sam, and
Okay.
we are looking for a Spark Connect session today. But I can stay back and we can talk about your specific issues.
Okay.
Sanya, Nitish, yeah. So just let's just wait for the session to be over for that. Sanya, Nitish, you want to go next? Sanya and Nitish are part of the Zing team, and let's have a quick round of introduction from both of them.
Yeah, hello guys. So I am working as a senior software engineer at Zing. I've been working for last 3 months. So like it's kind of pretty cool algorithmic work and all those things like we are doing here. Maybe as Sonal said, like maybe some other time we will arrange some other sort of session to explain how it's working, how end-to-end things are working. But today's session will be more focused toward Spark Connect with Sim. So yeah, thank you.
Yeah, so I'm Sanya and I've joined as a software developer. And yeah, it's been 3 months for me as well. And it's been awesome working with Zing. And yeah, uh, excited to hear about Spark Connect and its functionality.
Okay, so thanks everyone, and welcome to this closed group. I'm very excited to welcome Sam. And I have been working and chatting for quite some while now. I think almost 5 to 6 months now, Sam. And it's like just one developer to another, going over open source things. And the thing that has bonded for us very closely is the Spark connecting that Spark that Sam has actually been working on. But just besides the work that Sam has been doing for Zing, he's also a major open source enthusiast. He's also starting up an organization completely devoted to open source, and he has been releasing a lot of small plugins as well as very deep work with graph ar, it's arc, right? Graph arc and dq library for data quality. So I leave to Sam to discuss some of the work that he's been doing and then talk about Spark Connect. But very thrilled to have him here, and really looking for this informative session today. So thank you, Seth. Over to you.
Thank you for the introduction. Let me share my screen. Okay. Do you see my screen?
Yes, we do.
Okay. So my name is Sam. I am a software engineer, data engineer on my job, but here I'm not as a representative person of my company, but as a just an open source enthusiast. I like open source. I like to contribute to open source, and yeah, I'm working also on Zingg open source part, especially on a new Python API. And today I would like to share you what I know about a new Spark Connect, a new decoupled architecture, and the most important for us, for Zingg and for most of open source projects in Spark ecosystem, I would like to tell a little about Spark Connect plugin system. But before we go, we need to make a small step back and remember how Spark works under the hood. yeah, of course, it's a little simplification, but it should be enough for this presentation. So what happens when you write your SQL query or data frame? Actually, there is no data flow, there is no computations because Spark follows a lazy execution model. It is an opposite model to so-called eager model in pandas. For example, if you work with pandas data frame and you apply, for example, filter operation or select operation or group by operation, you will get results immediately because pandas will do immediate computations and that's it. Spark follows a different way. Spark follows a lazy execution model. So when you write your SQL query or you write your data frame operation, I'm sorry. Uh, okay. Okay. So when you write SQL query or create your data frame operations, um, Spark creates so-called logical plan. Logical plan is just a set of operations, ordered set of operations or graph of operations, and there is no computation at all because Spark do analysis, Spark do optimization of logical plans, Spark do physical planning, and actual computation, actual data processing happens only on the last step when you already have a selected physical plan, the most optimal that Spark was able to find. And yes, the code generation and the physical execution happens here on the last step. But this happens only if you call it, if you call so-called actions, because in Spark we have actions and transformations. And any transformations, any call to any transformations just created one more node in logical plan. So there is no computation. And yes, during the analysis, Spark resolve names of columns and tables to actual data files, checks types of data, apply optimizations, apply rules, generate a lot of physical plans, and choose the most optimal one. For example, if we just create a simple PySpark application that read Parquet file, rename one column, group by another column, and compute two aggregates, average and max. And after that, we just call explain. We will see both parsed logical plan or initial logical plan created directly from our data frame program and optimized final physical plan. And we already can see a lot of benefits of lazy execution model because, for example, this table contains 1, 2, 3, 4, 5 columns. But from the code, from the plan, Spark realized that actually we need only 2 columns. And Spark applies this optimization that we do need to select only 2 columns, but it happens it happens implicitly without our touch. And that's very cool because Spark can apply a lot of optimization, and that's the main benefit of a lazy execution model. Now let's talk a little about so-called Spark Classic or the current way of how Spark runs. So when we are running our Spark PySpark Python application, we have application layer, that's where our code is running, and we have a driver. Driver is already running in Java virtual machine, and interaction from PySpark to driver happens via so-called Java bridge. It's a way to call Java applications, Java classes, and methods from Python. And driver do parsing, driver do optimization, scheduling, and driver communicate with workers that are typically in Kubernetes cluster or Yarn cluster or something like this. So our application send to driver SQL or plan and get results. What was changed with Spark Connect? Spark Connect create a thinner layer between driver and application, and this thinner layer is it allows to run remotely to have remote driver. So actually, this Java driver and this Spark Connect API can exist on another server, on Spark server. And that's very cool because, for example, if I want to create a web application for my manager, that my manager is able to fill some forms and click one button and actual Spark application with these parameters will be run. with Spark Classic, I need to have all the Spark jars, all the Java things and dependencies on the same server where my backend is running, and it's not an easy thing because PySpark, for example, contains about 600 megabytes of jars, and Spark contains thousands of dependencies. It's a very big and complex project. And yeah, for example, if you want to work with Spark from Python, you have a pain that you're working not with Spark, but with Py4G. You have cryptic errors like class not found exception, or if you're using a wrong version of Java or wrong Java home and you are not familiar with Java world, it may be very hard to debug. If you are using Spark from Java, using Spark Java API, you may easily face dependency hell because Spark has thousands of dependencies of specific versions, and putting into your application another dependencies might easily tend to unresolved case when you just cannot build your project because of dependencies, and it is very painful. And yes, one more thing, as you remember, there is no actually operations on data until that moment. All that we have before is plan, logical plan, or this set of operation. And this is exactly thing that is sent from our application to Spark Connect API and back. And in the case when we request the data, yes, it is sent as Apache Arrow stream. Apache Arrow is a way of intercommunication between programming languages. Is programming language agnostic format of the data. And yeah, it's very cool because now you can, yes, at the moment we have PySpark, we have Spark R, we have Spark Scala and Spark Java. But with Spark Connect, you can have Spark Rust, Spark C Sharp, and who knows what else, because all that you need to do is implement a quite simple logic of creating gRPC requests. And Spark itself already define all the protobuf messages that needed to implement it. So what are benefits of Spark Connect? No Java home, no class not found exception, no dependency hell, no huge Python libraries, 600 megabytes, no needance to have all the jars, all the configurations on your local server. You can submit your task from anywhere. Another strong benefit is that if you want to have multiple people working on the same driver, it is almost impossible to achieve total isolation of user contexts because that's how Java works, and that's because of how Spark Classic was designed. But with Spark Connect, you can achieve shared isolation, and that the thing is used in database. I forgot to mention that today you already have some vendor provided Spark builds. The first one is Databricks Connect, that is the same Spark Connect under the hood. Another one is EMR serverless, that is again the same Spark Connect. So yeah, we have a lot of benefits of Spark Connect, but there are also some concerns. And yeah, the first thing is that you cannot call low-level APIs like RDD because RDD from now is a physical execution layer of Spark, and it is a part of so-called internal API. So, but it's not so big problem for me because in my understanding, end users of Apache Spark shouldn't call RDD APIs or something like this because this, yeah, all that users should want to do may be achieved by data frame API. No needs to go to the level of RDDs because with RDDs you do not have all this optimization. You need to care about everything by yourself. It's really hard story. But another big concern is that there is no JVM. And yeah, it may be controversial because it's a benefit and concern at the same moment. But yeah, the problem that there is no JVM is that there is no Java bridge tool. And let's talk a little why it is important. To understand why it is so important, let's take a small look on how PySpark itself is done. So if you go and take a look on PySpark source code, you will see that it is mostly about, it's not about logic. It's not about creating of plans, optimization, or something like this. It's just about bindings or calls to Java bridge. So this is an example of init of Spark session, init method of Spark session in PySpark Classic. And you can see that under the hood there is a Java Spark context object that is actually a reference to Spark context instance in Java virtual machine. There is a underscore JVM that actually a reference to Java bridge itself. And yeah, in Classic, developers can easily add bindings to their own Java classes because this JVM has access to all the jars or Java packages in class path. So all that you need is just to add a jar to your class path. And yeah, if you worked with Zingg, maybe sometimes you can face this error like class not found exception. That means that yeah, you just forgot to add the Java class and Python know nothing about this. But yeah, again, why it is so important for PySpark ecosystem? Because biggest part of PySpark ecosystem, I mean packages, third-party packages like data quality, entity resolution, machine learning, NLP, or something like this. The most of this code are done by developers who are very familiar with Spark itself, or actually are contributors to Spark itself. And of course, if you are a contributor to PySpark and you used to use Java Bridge for everything, you will build your third-party Spark package in the same way. And it's a big problem. And for example, Zingg is built in absolutely the same way. If you open a current version of Zingg code, Python code, it's just about bindings to Java. You create an instance of zing.spark.client.pipe.spark. It's actually an instance of Java class. You can call a method of this Java class, and actual method in JVM will be called. You can get a reference to Java objects, and at the moment, that is how Zingg API is done. And not only Zingg, because if you take a look on the Spark ecosystem, you will find a lot of projects that are done in this exactly this way. For example, DQ is a very well-known library for data quality, and PyDQ is built as just bindings, Py4G bindings to upstream DQ. I already mentioned about Zingg. Apache GraphR is a project where I implemented Py4G bindings by myself. It was about 6,000 of lines of Python code just to realize that today I need to rewrite it again to Spark Connect. SynapseML is a very famous library for machine learning application. You may heard about this by old name MML Spark. Graph Frames is a library to work with graph from Python, and it is done in Py4G in the same way. And all this library will be, yeah, all this library won't work with Spark Connect just because there is no JVM. I had a couple of talks with Spark core devs behind Spark Connect idea, and I asked this question like, guys, why you did not provide anything like Py4G? But actually, there are more problems with Py4G that we can think. There are a lot of underlying problems to call. There are problems with isolation, with security, and the answer from Spark devs was, while it is possible to re-implement Py4G, no one will do it. So we need to live with a new reality. What is a new reality? New reality is Spark Connect plugin system, and actually that's a quite cool thing. The only problem is that you need to rewrite your PySpark application to the new way. So what we can do with Spark Connect plugins? With Spark Connect plugins, there are three at the moment, only three, but I'm expecting there will be more interfaces that allows you to define your own plugin or thing for Spark Connect. And Spark Connect is only about protobuf messages and gRPC calls. The first plugin is like command plugin. It is a void or none in Python. And it's for the case, for example, when you want to run something, for example, update configuration. There are a lot of configurations in Spark. And for example, you want to run a command and update configuration. For example, specify Hive catalog name or your own configuration like Zingg catalog name or something like this. And this is about command. You just send a message and you are not expecting an answer. The second kind of plugins is expression plugin. It's about column. So for example, if you want to write your own logic to transform a column in Java or Scala using low-level Python APIs with do code again and all these things, you can do it. and register your column expression as expression plugin. But to be honest, I did not use this thing because it's quite a rare case. And the most important for me is a relation plugin. It's a plugin when you send a message to Spark and you get a data frame back. But because again it's Spark Connect, you are actually getting not data frame but logical plan that will be serialized. What is really cool is that developers of these plugins shouldn't care about creating gRPC requests, handling gRPC requests, implementing all this attaching, reattaching logic, arrow streams, because Spark will do it by itself. Spark will search for all the possible plugins, and if Spark find a plugin that can handle specific message you defined, Spark will use this plugin and care about all the gRPC, arrow, and all these other things by itself. That's very cool. And let's take a look on a real world example of plugins that work I did recently. As I already mentioned, DQ library. And yeah, I really like this library. I think it's very cool. And this is DQ. What is DQ library? DQ library is a very cool, quite low level Scala library that's used to build data quality. Actually, it's data quality engine, not a data quality tool. And there is a data quality tool built on top of DQ that is named Python DQ, but Python DQ is built via PyForge bindings, and it is not working in Spark Connect environment. So for educational purposes, I decided to create a Spark plugins, Spark Connect plugins for DQ. What did I done? I defined all the protobuf messages required to define all the main structures of DQ. I created a server plugin that can handle the message and parse this protobuf and deserializes protobuf to actual structures of DQ, create structures of DQ from protobuf messages, run DQ job, collect the result, and send result back to client, to user as a data frame. And also I created a PySpark API on top of generated from protobuf messages Python code, because yeah, if you work in your life with protobuf, it's quite a specific thing, and typically it is a best practice. Do not force users to use directly protobuf code. So yeah, what I have now, I have a Python API. So via this Python API, I can create DQ structures. Spark itself will care about creating gRPC request from my protobuf message, send it to Spark Connect server, and handle about attach, reattach logic, parse my plugin that I just registered via simple configuration, run the job, and send result back. So what it was about? It was about 350 lines of protobuf code. It's a simple example. So yeah, DQ is a data quality library, so you can run a different kind of data quality checks. For example, you can compute histogram, you can compute count, distinct correlation, all these things. So for each of possible DQ structure, I defined own protobuf message. I did the same for analyzers that I used in DQ. I did the same for anomaly detection strategies, some helper classes, check configurations, and the whole suite. I created a parser in Scala, about 500, 600 lines of Scala code that just parse protobuf messages to DQ structures. As you may see, this is a protobuf message. This is a code generated from protobuf message. So it's actually a protobuf message. And I just check each message for pattern matching with existing. And for example, if my message is for approximate count distinct case, I need to create approximate count distinct in DQ. And this is an instance of DQ object. And I just pass inside all the parameters from protobuf messages. So actually, protobuf messages, again, does not contain any kind of business logic. It contains only arguments for DQ classes. Protobuf messages contain only information that is needed to create DQ objects instance of DQ classes. Yeah, it's quite a boring pattern matching, like case, 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 but only 600 lines of Scala code. And to be honest, I heavily used LLMs to generate it because it's a perfect case for any LLM tooling to generate some bindings from existing protobuf messages. And the final thing is the implementation of relation plugin itself. So yes, what I did here, I create a message. Yes, this method expects a message, but in form of any. And inside my code, I need to check that this message is class of I expected, because if it is not, I should return empty. And in this case, Spark will trying to find another plugin that can handle this kind of message. I parse a data frame, but it's not a data frame, it's a logical plan I passed from my client. I create DQ suite from the message using my parser. I run DQ suite. I generate resulting data frame in for my font, and I just send it back, but not again, not in form of data frame, but in form of logical plan, because data frame is not serializable, but logical plan is serializable, and you can send it from one server to another. And that's it. I tested it and it works. It works fine. And yeah, after implementing all these things, I realized how cool this way is, because actually you can do the same thing for Spark Classic, because with protobuf, with already defined protobuf messages, you just passed here instead of a relation of logical plan, you just pass here a data frame via Py4G, via Java Bridge, and you pass the same suite you created from protobuf as bytes. And that's very easy, it's very cool, because it is only about one single call to Java Bridge instead of calling each method of Java Bridge, because working with Py4G may be really painful, especially if you're working with Scala. For example, if you want to have fun, try to realize how to pass an optional long from Py4G from Python to Scala. In my understanding, it's absolutely impossible. That's funny, but it's impossible. So that's it. What's next? Finally, we are on point when we ready to discuss Zingg. I'm working on a new PySpark API, PySpark Connect API for Zingg. I already defined most of protobuf messages for most of Zingg structures. We already had a discussion with Sanal. I created a server plugin, and it mostly works. And now we are here. We are testing the pipes with different kind of messages, corner cases. And when it is done, the last thing we need to do is to just create a simple user-friendly Python API. Again, because working directly with code generated from right above may be little tricky and unobvious. And you can easily create a user-friendly Python API on top via data classes, Pydantic, and all modern Python. Mostly that's all I wanted to tell today. Thank you for your attention. Feel free to contact me via email if you have some questions or ideas or want to collaborate on any of the project.
Yeah, thank you, Sam. This was very informative and very deep. So thank you for this, and thank you for all the hard work that you've been doing on a lot of the open source projects, including Zing. I do have a few questions, but I think before that, if anybody else has some questions they would like to ask. Okay, so I think I'll go next. I'll go first then. So in terms of like this API which is Python bound, but then there are so many Spark connectors that Zing specifically uses for JDBC connection, for NoSQL connection to, let's say, Cassandra or to Elastic or to Snowflake, the typical data frame APIs. In the new world of Spark Connect, how does that work?
It works in the same way because, for example, yes, okay, you want to connect and read your data frame from Snowflake, no problem at all. You just add a needed jar to your Spark server, not to client. You send via a gRPC message information needed to connect. For example, I don't know, URI of connection, I don't know, some token or something like this. And a Spark server will call Snowflake, read Snowflake data source internally, and return your logical plan of it. Because again, Snowflake implements data source v2, as I remember, and you can reading Snowflake table via Spark. It's just about this creating a logical plan, like source is Snowflake, and you do your operations. So in my understanding, there is no principal difference. The only difference is that you are calling it not from your application, but from the server. And in this case, you need to care about connectivity of your server to Snowflake or any other data source you want to use. And also you need to care about your class path of your server should contain jars that implements data source. But it works in the same way.
Okay. It will
For
obviously.
example, this DQ story, it's about the same. I'm adding a DQ jar to Spark server because DQ obviously is not a part of Spark distribution.
Mhm.
And I'm calling these low-level APIs RDD things from DQ in my Spark server. And my client shouldn't care about this because interaction is via gRPC.
So just to be clear, on the client side, it's just the Python installation or the Python package of, let's say, Zing or DQ, and it's only on the server side of Spark where we have the actual DQ jars or the Zing jars, which we need to care about that they're part of the Spark server installation or part of the driver, like the Spark server running, so that when the relation the plan gets translated, the relation plugin or the appropriate plugin is at least available to be for those messages to be handled. If that is that my understanding correct, right?
Yes, yes. You need only to add your jars to server. Actually, at the moment, there is no tiny Python distribution because even if you want to install PySpark with Connect, you will download the whole Spark. But they are actively working on this. There was a voting in PySpark mailing list recently, and this voting passed successfully about creating a Java-free PySpark distribution. So we should expect a Cine PySpark client, not a 600 megabytes Python library with all the JAX packet inside, and it will be just a Cine Python that should work almost without dependencies, only protobuf gRPC and maybe some PySpark code, and that's it. And for me, it's very cool because and nothing principally changed. Now all the things happen in server, and for me it is even simplification for users.
And I think second question is that some of our users have been interested because they come from the data science background, and some of them have requested me for the R bindings, not the Python API, but the Zing R API. And I assume that, with all the work that you've done on protobufs, it's just a matter of writing the R client because those messages are already defined. So defining the R API is what I assume
It's
bulk of work there.
it's very complex question.
Okay.
First thing I want to say is Spark R itself is deprecated. Voting passed successfully. They voted recently in Spark mailing list about deprecation of Spark R. So new distributions of Spark will contain only Spark Java, Spark Scala, and PySpark, not Spark R. Instead, it is strongly recommended to use Sparkly R library from this deploy R ecosystem. I recently made a first look on. I recently take a first look on how it is done under the hood, and I was surprised that Sparkly R is working via calling Python, PySpark. So actually, it seems to me that you do not need even to generate your R code from protobuf because I'm not even sure that it is possible. There are some third-party, because R is not supported by Proto C compiler. you can try to find a proto compiler that compiles R code, but I'm not sure that such thing exists. But you can generate Python code, Python classes, because ProtoC Python is the first class citizen in ProtoC compiler, and you can add these Python libraries to this Sparkly R distribution. And all the thing you need to do is a very simple R APIs that are calling underlying PySpark. So in my understanding, it should be absolutely enough to create PySpark bindings and very simple, very tiny R bindings to these PySpark bindings, because Sparkly R itself works via calling
Okay.
PySpark.
Okay, that's a fine then. Okay, so that's a new one to me. So I'll probably put that as a project somewhere. We'll probably investigate this a bit more then. But this seems cool, right? I think we should be able to leverage the work that we have then on Zig Python
Mhm.
and go from there then. Okay.
Yeah, also there are actively maintained at the moment projects about creating Spark Connect Go. And Golang is the first citizen in ProtoC compiler, so
Yes.
you can generate protobuf classes for Golang. Yeah, it's quite raw, but mostly working already. I knew people behind Spark Connect C#, and also there is Spark Connect Rust. So in theory, you can support all of this using only single set of protobuf messages and single Scala or Java plugin for server. All that you need is to generate corresponding messages and create maybe an API on top to simplify life of users. About Sparkly R, I will send you links what I found to direct messages.
Yeah.
Yeah, I have one high level question, Sam. Like, I just want to ask, like, so basically, this Spark Connect is kind of a wrapper or gateway in front of this Spark cluster, right? So for a end user, they are just concerned about firing request to this this Spark Connect, right? They need not worry about underlying Zing or Spark that is sitting behind this Spark Connect, right?
Yeah,
Uh,
exactly. Exactly.
And so the next question is, so once a request come to this Spark Connect, so like Spark Connect will then interact with both Spark cluster, Spark core jars, and as well as Zing API jar, or how is it like? Uh, you need
What
to
happens?
change some code inside Zing core as well, right? To means my question was, so end user will fire request at Spark Connect, then Spark Connect has to interact with both Zing jars and a Spark cluster jars that are residing within Spark cluster, right? Spark jars
Yes,
basically.
yes, yes. When you send a gRPC request to Spark Connect server, and this gRPC request is a type of extension, because all these plugins should be registered as extensions. Spark will check the configuration. There is a specific configuration like something like Spark Connect plugin extension relation, and you need to register your class of your plugin as an extension. But it's again about one-time configuration of the server. In this case, Spark will check all the registered plugins until it finds a plugin that is able to parse the specific message you sent. If Spark won't be able to find this plugin, Spark will send back a message like, I'm sorry, there is no registered plugin to handle message of kind, and provide the name of the class. So if your customer forget to register Zing plugin in Spark Connect server, your customer will get an exception like, I'm sorry, but message of kind Zing message something cannot be handled because there is no plugin. And actually, this message can be also handled on the client side. For example, in your Python code, you can check for return code from Spark Connect, and for example, in this case, provide even more explicit message like, we are sorry, but you need to add this jar to the Spark server and add this configuration or something like this.
Okay.
Actually, it works in this way.
So like and like whenever like so one time we have we created a jar and we have stored that jar in a Spark cluster. Next time when we add some feature to our product and create a new jar out of it, then we need to change. We will then store new jar in the Spark cluster. For example, new Zing build jar in a Spark cluster. Then do we need to do changes in a plugin as well, or at a Spark Connect site as well, if we are adding some features or whatever, some core functionality changes and also that just want to know this as well.
Yes, of course. If you are providing new version of your library, Zing, you need to provide these updates and deliver this jar, the new version of jar, to Spark server. So yes, jar with Zing logic and also with the Zing Connect plugin should be in a class path of Spark Connect server. And that's it. And the class you created for handling gRPC message should be registered as a Spark extension. But the simplest part, I will show you how it should be done. It's really easy. It's a couple of line of configuration.
Okay. Okay. Yeah. Thank you.
Amni has a question. Raise your hand.
Yes, hello. Hi, do you hear me?
Yes, we can see
Yeah.
you and hear you.
Yeah.
Hi, welcome.
Okay, hi. Thank you, Sam, for this very interesting presentation. As a data engineer, I just was wondering if there is any benefits that Spark Connect offers in ETL workloads, especially in cloud-based platform like Databricks or Synapse or Fabric, for example.
Yes, I already mentioned shared isolation. And at the moment, shared in Databricks, I forgot how to name it. It's something like shared isolation mode or something like this. And yeah, it is achieved by Spark Connect, because without Spark Connect, it's really hard to achieve a total isolation. But Spark Connect is designed to provide multi-user. So you have a single server, and you have a multiple customers that connect to the server, and this server works as a gateway. And these things, for example, is under the hood of Databricks serverless or EMR serverless. And from an ETL developer point of view, for example, startup of Databricks cluster, classic Databricks cluster is about, I don't know, 3-5 minutes or something like this, because it need to find instances in AWS or Google Cloud. You need to run init scripts, set up Spark, set up all the jars and all the connectivity. But with the serverless, uptime time is about seconds. So you can get a ready to use endpoint, and that's quite cool for me. Also,
Okay.
if you are working as an ETL developer and you are writing in Scala, there is a very nice project at the moment about creating a Scala 3 tiny client, because if you are working in a gRPC way, you actually do not need to care about all the Spark classes. And it is very simple to create Scala 3 Spark version. And yes, that's very exciting. I'm waiting for release of this project. But even if you are working with a Scala 2 or Java, with Spark Connect, you do not need to have all these dependencies of Spark, and it's much easier to maintain your dependency and avoid dependency hell, because Spark has thousands of dependencies, and if you try to create a simple application that has own dependencies, it won't be an easy task to synchronize all these things. So I see a lot of benefits, to be honest.
Okay. Thank you.
Any other questions, anybody? Okay, cool. So I guess this was it. And thank you, Sam, so much. I hope you enjoyed giving this talk as much as we enjoyed listening to you. And it's been a great learning experience for me personally, as well as for this group today. Thank you so much for joining us.
Thank you. Thank you. I will send my slides to you. Please share the slides in the chat.
The recording as well as the slides, we will publish them on our YouTube channel as well as on the on our website as well. So thanks Sam again. And I'm staying back just in case anybody has questions around Zingg, I can answer right away. Happy to.
Okay, I'll leave. Thank you.
Thank
You,
you all.
Sonal. See you.
Yeah,
Bye.
thank you. Thank you, Sam. Thank you so much. Bye-bye. I'll just stop the recording as well.